Hello everyone, so today we're going to go over section 6.5, dividing fractions and mixed numbers. So we'll begin by going over dividing fractions using diagrams. As you can see here, we have a couple of diagrams. The rectangle on the right is going to be representing 1, and the diagram on the left is going to be representing 1/4. So the question asks how many 1/4s can fit in 1. And of course, we can see that if the square on the left is 1/4, then 4 of them can fit into the rectangle on the right. So each one of these will be 1/4. So first quarter, second quarter, third quarter, and the fourth quarter. And what that means for us is that 1 divided by 1/4, as we can see on the right, is going to be equal to 4. Okay, so the next example is similar. So we have here the square on the left. This time is going to represent 1/2. And so the first rectangle on the right-hand side, this is going to be representative of 1. And of course, then this square is going to be 1/2. The question is, how many 1/2s are in 1.5? And then the answer to that question is going to be 3. First 1/2, second 1/2, and third 1/2. If we are then to write this as a division question, we have 1.5, so divided by 1/2 is equal to 3. Okay. So one more, we have rectangles on the right. Again, these are going to be representative of 1. So this is 1, 2, and here we have 1/3. And on the left-hand side, this rectangle is actually 2/3. You can see that it is 2/3 the width of the rectangle on the right, that representative of 1. So in this case, the question that we're asking is how many 2/3 are in 2 and 1/3. So this is a bit of a trickier question. So let's see if we can draw a diagram that makes this make more sense. So this is 1 2/3 right here, and second 2/3, and then we have a third 2/3. And this square here is actually 1/2 of 2/3, which makes sense because it's 1/3, and 1/3 is half of 2/3. Okay. So here we have a 1, another 1, a third 1, and then here 1/2. Okay, to combine what we are dividing here, we have 2 and 1/3 divided by 2/3 is equal to 3 and 1/2. Right? We can see that 3 and 1/2 of these 2/3 rectangle fits inside the diagram on the right. Okay. Let's go ahead and erase this. Okay, so from there, we have a second method of dividing. We're going to divide using common denominators. To divide fractions, we can write common denominator and then divide the numerators. So let's see how this works. So first case, we have 3/4 divided by 1/8. So we can rewrite 3/4 as 6/8. And then we divide it by 1/8. And if we just divide the numerator, 6 divided by 1 gives us 6. So you can imagine drawing a diagram of 3/4 and then splitting each one of the quarters into 2. That will give us 6/8, and then we can fit 6 1/8s inside of there. So the answer is 6. Okay, second example here we have 5/6 divided by 2/3. Once again, we can rewrite them to have a common denominator. So that will be 5/6 divided by 4/6. Notice that in this case it doesn't divide evenly. We're left with 5/4, or 5 divided by 4. Okay, which of course can be rewritten as a mixed number 1 1/4. Okay, which makes sense if we drew diagrams for this this question, and 1 1/4 2/3 will fit in 5/6 is a good way of interpreting what we just looked at. Third question. Okay, so the first thing we're going to do is rewrite 2 1/2 as an improper fraction. So this will be 5/2 divided by 3/4. Again, common denominator, so this will be 10/4 divided by 3/4, which means we're left with just 10 divided by 3, which can be rewritten as 10/3, and then as a mixed number 3 1/3. Okay, so that's two different methods of looking at dividing fractions. But the first one, the diagrams, is not very quick because you have to draw the diagrams, and using common denominators is actually not the fastest thing we can be doing for dividing either. So let's look at what else we have in store. So here we have recalling 6 divided by 2. So back when we looked at integers, when we divide 6 by 2 as two different meanings. So this would be either 6 objects into 2 groups, or 2 equal groups. And then that will be 3 objects per group. And then another way of thinking about division is, of course, 6 object into groups of 2. And we have 3 equal groups, or 3 groups. Okay, either way, 6 divided by 2, of course, is equal to 3. So now we're going to look at this question here. We have 6 times 1/2. What is really happening? Well, if we have 6 times 1/2, we have 6 groups of 1/2. Which is equal to 3 groups of 1. So in other words, 6 times 1/2 is equal to 3. Notice that 6 divided by 2 and 6 times 1/2 gives us the same result. And from the first page, we saw 1 divided by 1/4 was equal to 4. And the way that we can think about this is, once again, one object into groups of 1/4 gives us 4 groups. And notice that 1 divided by 1/4 is the same as 1 times 4, which of course also gives us 4. Okay, so we can generalize this result by saying dividing by the fraction a over b is equivalent to multiplying by the reciprocal of the fraction b over a. So here reciprocal means we write the fraction upside down, or flipped. Alright, so if we are dividing fractions without models or diagrams, which is what we did back on page 1, there are 4 steps. Alright, step 1, write mixed numbers as improper fractions. Okay, step 2, find the reciprocal After that, we can multiply instead of divide. And finally, we can reduce and rewrite as necessary. Okay, so let's look at, first of all, reciprocals. So an example here, a reciprocal of 3/4 is 4/3. Reciprocal of 5 over 9 is 9 over 5. Now, if we have a whole number, such as 8, notice that this is equal to 8 over 1. So its reciprocal will be 1 over 8. It's very important. From there, we have a couple of mixed numbers. In order to find the reciprocal of mixed numbers, we need to rewrite them as improper fractions first. So in this case, 4 2/5 is the same as 22 over 5. So the reciprocal will be 5 over 22. Likewise, 2 4/7 is the same as 18 over 7. So its reciprocal is 7 over 18. Okay. So from there, now we can try our hand at dividing using the method that we just described. First example here, 1/9 divided by 2 over 7. Find the reciprocal of 2 over 7, which is, of course, 7/2. And then we multiply instead, and this will give us 1 times 7 is 7, 9 times 2 is 18. So 7 over 18. Next up, 4 over 5 times 10 over 3. So just as before, we can simplify a little bit first. So 10 and 5 are both divisible by 5, so that simplifies to 2 and 1. And from there, 4 times 2 is 8. 1 times 3 is 3. And of course, we can rewrite this as a mixed number. This will give us 2 2/3. All right, following that, we have 10 over 9 already in improper fractions, and then we will multiply by the reciprocal of 5 over 6, which is 6 over 5. Again, we can simplify, so 2 and 1 in place of the 10 and the 5, and both 9 and 6 are divisible by 3. So ultimately, we have 2 times 2 in the numerator, which gives us 4, and 3 times 1 in the denominator, which gives us 3, and that could be rewritten as 1 1/3. Oops. So the next three example involves some mixed numbers, so you can rewrite them as improper fractions first. So in this first case, instead of 2 and 2/5, we have 12 over 5. And then the reciprocal of 8 over 15 is 15 over 8. Again, we can simplify before multiplying in this case. So 12 and 8 simplifies to be 3 and 2. And then 15 and 5 can be reduced to 3 and 1. So I'm going to multiply the resulting numbers together. So this would be 9 over 2. And as a mixed number, 4.5. Right. Next one, very similar. 3 times 6 is 18. 18 plus 1 gives us 19 over 6. And then divided by, let's see here, 1 times 3 is 3. 3 plus 2 is 5. So this would be 5 over 3. And then we will multiply by the reciprocal. So this would be 19 over 6 times 3 over 5. Again, we can simplify a bit here. So 2 and 1. This will give us 19 over 10, which is the same as 1 and 9 over 10. Sorry about that. Okay, one more. Same thing here. Numbers are slightly bigger, but that's okay. 32 plus 13 is 45 over 16. Divided by, let's see here, 48 plus 7 is 55 over 24. And then second step, we are going to rewrite this question as a multiplication question. Multiplication question. So 24 over 55. Notice that both 45 and 55 are divisible by 5, so that leaves us with 9 and then 11 on the other side. And then both 24 and 16 are divisible by 8, so that will give us 3 and 2. So 9 times 3 is 27, of course. 2 times 11 is 22. Finally, we can rewrite this as a mixed number. That would be 1 and 5 over 22. Okay, so a couple more questions here. We have a couple word problems. Vince usually takes 5.5 hours to drive from Kamloops to Banff. Because of a snowfall, the drive took 8.25 one day. How many times longer than usual was the drive? So, in order to find that out, we need to divide 8.25 by 5.5, which is the usual time. So we're going to rewrite these as improper fraction. 8 times 4 is 32, plus 1 gives 33. And then 5 times 2 is 10, plus 1 is 11. Going to rewrite this as a multiplication question, as usual. So this would be 33 quarters times 2 over 11, which again simplifies. So here 33 and 11 gives us 3 and 1, and the 2 and the 4 gives us 1 and 2. So this will be 3 times 1, which is 3, and then 2 times 1, which is 2. So it is 1.5 times as long as usual. Okay. Finally, we have example 5. Sabrina has 3 1/3 liter of ice cream to share equally amongst herself and her 9 friends. How much ice cream will each person get? Okay, so there are 10 people in total. So we have 3 1/3 divided by 10. Again, we're going to rewrite the mixed number as an improper fraction, so that will be 10 thirds. And then we will rewrite it as a multiplication question. Okay, in this case, the tens will simplify to be ones. So we get a final answer of 1/3 liters of ice cream. Right, so we looked at how to divide fractions using diagrams, and then we divide fractions using common denominators, and then finally we divided fractions using the reciprocal method. And that's it for today, so thank you for listening.